In this lesson, we're going to specifically discuss inverses, which will lead us into polynomial functions. So today's lesson is looking at the tables and graphs and graphing inverses. So in our first slide, we're going to talk about what an inverse function is. Inverse operations are operations that undo one another, like addition and subtraction, multiplication and division. We also have inverse functions which, quote unquote, undo each other. One example is y equals x squared, which is a little parabola shape function. And its inverse would be a square root function, y equals the square root of x. Now the domain has to be restricted, but they would be inverses of one another. And you will see that as we go through, our inverse functions have to reflect this line y equals x. So that is the next little blop that we need to put into our notes right there. Reflect across the line y equals x. We can recognize them, these inverse functions, in tables and in graphs by comparing the input values, which are the domain. You can also consider these the x values. So think about an ordered pair. We have an x and a y. So we're going to compare the domain or the input values with the range, which are your output values. And those you could call your y values of an ordered pair. Okay, and then as we go through, we're going to be given a function f of x, and we can state that the input or the domain of its function will become the range of its inverse. That means the x's of the original function become the y's in the inverse function. Therefore, the range or the outputs of that original function become its domain, or the x's, of its inverse. Okay, so very, very basically, what are we doing? We are just switching the x and y values of an original function to create its inverse. So if my original function is xy, its inverse, just looking at an ordered pair, will become y comma x. We're just taking domain and range and switching their places, or input and output and switching their places. All right, so let's go through some examples. So our first examples are in tables, and you'll notice that we have in this first setup here, we have x and g of x and fx and f of x. So the domain, -3, becomes the range of its inverse, and the range of the original function g of x becomes its domain in the inverse. So I just want to look across and see, does the point -3, -2 become -2, -3? It sure does. Now check each of those points. -1, -1. Okay, they're the same number, so when I switch them, they'll become -1, -1. And then the same for the origin, 0, 0. Its inverse point would be 0, 0 as well. And our last one to check is the original function g of x has a point 2, 1. The inverse function has a point 1, 2. So that means, yes, those two functions are inverses of one another. Great. When we look at example 2, we're going to check the domain, the inputs or the x values, with the range on the other side, and the range of the original with the domain of its inverse. So our first ordered pair is -4, 8. Its inverse should be 8, -4, but they're missing the -4. So based upon that first point, it's not an inverse. All right, let's check the others. 3, 4 should be the point 4, 3. They've switched them, but they've also made that original domain value a negative. Same with the last 2 points. 7, 6 should be 6, 7, and they have a -7. And 12, 1 should be 1, 12, but they have a -12. So because these values in the range of the inverse are not the exact same as the domain, they're not inverses. And then our last example, this one is just crazy shapes. So I have an input column and an output column. The input is a star, output is a circle. Its inverse would be input of a circle, output of a star. So just look at these shapes and verify a smiley face. What is that? A smiley face and diamond becomes a diamond and a smiley face. An X and a call out becomes a call out symbol and an X. And a ribbon and a no shirt, no shoes, no service becomes that same sign and then the ribbon. So that last example is also a set of inverses. Input and output switch places. All right, in examples 4 and 5, we're going to create the inverse. Our original function for number 4 says a cow goes to the barn, monkey to a tree, dog to a house, turtle to the sea, and a bird to the air. So remember, all of these outputs, the places where the animals live or stay, will become the input. So we should have a barn, a tree, a sea, a house, and the air. The tree goes to the monkey, the sea goes to the turtle, house to the dog, air to the bird, and barn to the cow. And it doesn't matter which order you write those in. I just copied the original output values in that same format and then rearranged them with the correct outputs. All right, and then our last example of this, our original x and f of x is negative 8, 11, negative 5, 9, negative 2, 7, 0, 5, and 3, 3. As we go through and do the inverse, we should have 11, 9, 7, 5, 3. So the original outputs or range becomes the new input or domain. And then their corresponding new range values were the original inputs or domain. Negative 8, negative 5, negative 2, 0, 3. Just make sure you have those ordered pairs flip-flopped. Now we're going to go through some examples where we're going to graph the inverse of the given function. In example 6, you'll notice the function that we have graphed, and I've already listed or put points on some of the really good points of the graph. And those are the points 2, 0, 3, 1, 5, 2, and 9, 3. Remember, to get the inverse, we just take those original points of the original function and switch domain and range, switch the x and the y to give us 0, 2, 1, 3, 2, 5, and 3, 9. When we plot those points and connect the curve, we get that shape, which is the correct inverse. I'll do that for a few more, and then I'll let you guys practice a couple on your own. So example 7 is up next. All right, graphed in example 7 is actually a cube root function. This is the cubed root of x. And I've plotted the points. I've already got them going. So we have our first point going from left to right is negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and then positive 8, positive 2. So the inverse points, remember, we're just going to switch x and y, switch domain and range, giving us negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. When we plot those points and connect the curve, we get a cubic function. There you go. There's a better version of that particular example. Our last example to do together is example 8. This one's a little bit different because it's not a typical function. It actually isn't a function. It doesn't pass the vertical line test. But we're going to use the points that we have that are definite points. So we have the point negative 3, 3. It then connects to the point negative 1, 2, which then connects to the point negative 2, 1, and lastly to the point 0, negative 2. So the inverse points, switch domain and range, switch those x and y. We're going to start at 3, negative 3, connect it to 2, negative 1, connect that point to 1, negative 2, and lastly to end at the point negative 2, 0. So we'll see those points being plotted and the connection as they go through. And then that is the correct version of that particular inverse. In examples 9, 10, and 11, you have examples similar to what we did in 6, 7, and 8. So you should try those on your own. Number 9 is very similar to number 8. Make sure that you pick a particular beginning point and ending point. So if you want to start at the point -2, -1, that's fine, and end up at -1, 3, or vice versa. The graph that you should get should have the points -1, -2, and then -2, -3, -2, -3, 2, 0, and 3, -1. Okay? In example 10, we have what is considered a square root function. So its inverse is a quadratic x to the second power, but we have to go by a specific domain. So we'll use the points that we have, -3, 0, -2, 1, and so forth, and we will get the following portion of a quadratic. You'll notice this would be like the other half would go this way to the left. Okay. And last but not least, number 11, its inverse. Those points you need to kind of find them as best you can. They're kind of in between values. So I would use the point -2, -4, and then probably -1.5, -1.5. That looks about right. 0, 0. And then I have the point 1.5, 1.5, and then the point 2, 4. So I would use those points to help me plot the inverse of that particular function. Great job with graphing inverses. We'll see you for another lesson soon.